Geocaching and Transformations, Using Geometry with Geocaching. The big idea: tracking, locating, and investigating locations. A global positioning system, a GPS, is a satellite navigation system that receives data via satellites in space. It can be used to track vehicles, equipment, mobile phones, people, animals, and more, and is used in privacy and by business on local and global levels. The engineering design process. Possible essential questions. Can we use a GPS navigation system to locate a person or place? The challenge. The president is visiting the city of Goshen to give a public speech, but doesn't want the general public to know that he will be here because of security reasons. The president has been hidden somewhere in secret for safekeeping. Your security team has specific orders from the White House to locate the clues on school grounds and recover the president without reporters finding out. The challenge criteria. Students will work in teams of 3 soldiers and will create a map on a coordinate grid of the school using geometric transformations. Each map must contain 8 waypoints that will lead the other group, the security team, to the president from a starting point to an ending point using latitude and longitude and a compass. The waypoints must consist of 8 geometric transformations. The materials given are a map of the school's front and backyard on a coordinate grid, a compass, a satellite map from an app or a smartphone, tools for transformation, mirrors and patty paper, and paper to write down your clues. With the redesign, reporters and paparazzi have taken over Quadrant 1 on the grid. Students must redesign their map, avoiding all of these areas. The guiding questions. How is a GPS system used? How are satellites involved with the locating of specific locations? Do you know why the latitude and longitude system was created? Would you know how to get yourself home if you were lost using a map or other means? How can a compass be useful in navigations? How does a GPS system relate to mathematics and the coordinate grid? What transformations can figures undergo that enable them to remain congruent to the original image? How can we prove a figure is congruent or similar to another figure by a series of translations, rotations, and reflections? The hook. Students will participate in a geocache hunt on school grounds. The hunt will teach students to 1. Use GPS receivers, 2. Relate latitude and longitude to a Cartesian coordinate grid, and 3. Collaborate and problem solve. Lesson 1. Latitude and longitude. Lesson 2. Coordinate grids and geocaching.
And then it helped you learn dilation, rotation, and translation a lot better. Yeah.
How to work together.
I feel like we learn more by socializing, not really socializing, but communicating the problems, and this helps you learn a lot more. Let other people think about the problems.